Hi, Alex. Thanks for joining us this afternoon. This is David with CalWatch.
Hi.
Hi, thanks for hopping on.
Yeah.
Um, yeah, so I'll just go ahead and jump and get started. So thanks again, Terry and Alex, for joining us. My name is David. I'm with um, Tracking California, a program of the Public Health Institute. We're the ones helping to lead CalWatch along with Big Valley Rancheria. So I'm joined with Susan Paul-Yukonis, who's also from Public Health Institute, Sarah Ryan from Big Valley, Dan Pomo Indians, and Sydney Little from the State Water Resources Control Board. They'll introduce themselves as we continue the presentation. But thanks for joining us again, and we'll go ahead and jump right in. So just to tell you a little bit about our program and why we're interested in HABs in and around Clear Lake. So we're currently in our fifth year of the project, and we're interested in studying HABs around Clear Lake and Lake County because there's been an increase in blooms for over a decade. Um, Warmer temperatures, nutrients being added to the lake. And many residents and visitors have complained that it's become more common, they're longer lasting. Um, they've noticed bad smells. There's different health impacts, both human and animal cases that have been reported around Clear Lake. So we're really interested in knowing more about HABs. And just to give you some background, the state requires notification and supports monitoring of tap water in systems with 5 or more connections, but little or no surveillance for what we're calling self-supplied systems. Just here's some more definitions. So public water systems are those that include treatment and regularly serve 25 or more people for 60 days of the year, and those are regulated. So you'll hear companies, for example, like you might have heard Golden Water State Company, Clear Lake Oaks County Water District, Konocti Vista Water. Those are public water systems, and there's 17 of public water systems that are located around Clear Lake shoreline and serve about 44,000 people. We're focusing on self-supplied systems, and these are unregulated drinking water treatment systems that supply households that have fewer than five connections. And so you can see from the slide, there's approximately 493 households that receive self-supplied systems around Clear Lake. And approximately 3,600 domestic wells, or about 15% of the population, receives water from domestic wells in Lake County. So we're going to be getting into this a little bit later, but treatment barriers are protective measures to minimize water system contamination, and then disinfection residual. When we talk about that, we're talking about like chlorine and bleach systems. There's a residual that there's still some protective quality available after reacting with other compounds that remains afterwards that we can measure. So what is our program, CalWatch? So it stands for the California Water Assessment of Toxins for Community Health, and it's a 5-year grant from the Center for Disease Control, and it's really to learn about self-supplied water systems and safety, as well as monitoring harmful algal blooms around Clear Lake and Lake County. And as I mentioned before, it's a partnership between all of the different organizations listed here. So Tracking California, Big Valley Band of Pomo Indians, the California Office of Environmental Health Hazard Assessment, State Water Resources Control Board. Um, yeah. So in our second and third year of the project, we wanted to identify all the homes in Clear Lake that are not supplied by a public water system. And we also wanted to identify individuals who made changes to their treatment system after results were returned from the first year. So I think you should have, to participate in the program, you should have completed a consent form as well as a questionnaire that had information about your system and any treatment that you were doing, and then also about your household. So we asked you to fill those out, and then we tested the water over the course of whether you participated in 2022 or 2023. We tested for nitrates, bacteria, total coliform, and E. coli, as well as cyanobacteria and cyanotoxins. And I think Sarah will be getting into this later, but you should have received a packet of information with your results and different education materials, resources, different actions you could take. And as this project is still going on, we're working with state and local agencies to try and help solve water access problem issues that were identified. So I'll turn it over to Sarah, who will talk a little bit more about the role that Big Valley has in the project and what they do.
Hey everybody, so nice to see you all, and I'm really glad to see that some of our participants came to this tonight. I know I've spoken with everyone here, and you probably are aware of some of the work that Big Valley does in the county. Big Valley, the tribe I work for, there's 7 tribes in the county, and Big Valley Band of Pomo Indians is one of them. I'm the environmental director for the tribe, and have worked for them for more than 20 years. And we helped develop this project in order to understand if there are any vulnerabilities for people's private drinking water systems because people rely on them to, take showers in, to drink, to cook with, and we know that the lake is challenging. And it was really great to be able to expand out to homes that were pulling water from creeks or wells that were near creeks for the second and third year. Um, but we also do. And in addition to, of course, this project, we started a cyanotoxin monitoring program on Clear Lake back in 2014. And so we've been doing cyanotoxin analysis or sending off for cyanotoxin analysis since then for over 20 locations on the lake shoreline and are really looking at how cyanotoxins are impacting all the different uses that people use the lake for besides drinking water and, recreation and all of that. We also respond when there are fish kills or when there are human illnesses or animal illnesses that are considered to be possibly happening because of cyanotoxins. So we go take samples of the water and get it over to the state if that's what they're wanting, and also do a lot of outreach. We have a couple of social media pages, Clear Lake Water Quality being one of them, and also on our website where we put the cyanotoxin uh, data for our lake monitoring program. We continue to work closely with the agencies about the different ways that people are being impacted by environmental issues, including cyanotoxins. And so we are, wanting to make sure that as many protective measures are out there as possible and that there are good policies and management for the watershed. So with this program, which started as David said, we're in year 5, but we went to all of the homes who filled out the appropriate forms and were eligible um, to be sampled, and reached out to all of you about your treatments for your drinking water. And so that's how we were able to get information that we're going to be talking about today about the different types of treatments that were out there for all the homes that we sampled in years 2 and 3. And and then we're comparing the data that we got with the type of treatment that folks had, as well as just looking at how effective certain things are. So in some cases, we did cyanotoxin analysis of people's tap water, but that was only if they were located, if they had intakes on the lake or on a creek. Go ahead and move to the next slide, please. Here is a graphic of what our information looks like regarding the toxin levels of our sampling locations. There's a QR code right there. You can also go to bvrancheria.com/Clear Lake cyanotoxins, and you'll find that. We have signage that is associated with each of these locations, which many of them are public access areas, parks and things. There are a couple of locations that are at homeowners associations or private homes. We tried to get sampling locations all around the lake. And we are coordinating with what the state recommends, which is a caution warning danger signage depending on the toxin levels. And, of course, because people's intakes into Clear Lake are, maybe 50 or 60 feet out, certainly a lot closer to the shoreline than what the public water systems have. We definitely see a relationship between the toxin levels along the shoreline and the toxin levels that are in people's tap water. Next slide, please. And for years 2 and 3, you can see the map of where those sample or those households are located. As David mentioned, in years 2 and 3, we expanded out beyond just the intakes and wells that were along Clear Lake, and expanded to other water bodies in Lake County, including creeks. And you can see on the slide that most of what we sampled in years 2 and 3 were wells, but also we had some intakes for a total of 55 locations in years 2 and 3. And next slide, please. And then when we got the results, and I always, had a talk with each person about what to expect, we sent the lab results back to the participants, as well as you can see the packet, some of the information that we put together to very clearly point out to folks what the recommendations are if your tap water tested at a certain, if there was presence of bacteria, for example, or if you had nitrates at a certain level. And that information was sent out, as well as the lab results. And of course, if you can't locate it, or for some reason didn't get those packets, you can see the email address below, info@trackingcalifornia.org. We are happy to send it out again. And that information was, as I said, shared with each individual so that they could make some decisions about if they wanted to do any servicing of their drinking water. And we also provided some resources in terms of who to contact if you think you need some more help with this. And there's also, of course, local service providers who can assist with, improving and optimizing your treatment for your home. And the next slide, please. I think we are moving. Oh, last slide for me. So what we tested for was bacteria. So presence of bacteria, basically E. coli and total coliform, and nitrates, which we found in a lot of the wells, but not really in the intakes. We looked for cyanobacteria, just the presence of the cyanobacteria in your water, as well as the toxins that it can produce. And you can see the public health thresholds that when we responded to you and provided the lab results, we said, okay, your result was this amount, therefore this is what we're recommending based on the public health thresholds. In a lot of cases, it's a do not drink, do not boil, and that is something that maybe a lot of people are not aware of. So we're really happy to get that information out because, as David stated, self-supplied systems are not regulated, and you really don't get a lot of support necessarily from other agencies. So we were really glad to do this project because we're able to get some information to you firsthand. All right, next slide, please.
Okay, thanks, Sarah. So we wanted to just stop here briefly and see how you might, this is just a scenario. We want to just pause and test your knowledge. So if you're a well owner and you decide to collect a water quality sample from your tap, and the results are as followed. So the results show that there's total coliform, there's no E. coli, and nitrate concentration is at 4 milligrams per liter. You want to go ahead and come off mute or just enter in the chat. Are you at risk? If so, which contaminants, and then what actions might you take? Any thoughts?
Well, I'm happy to get that started.
Thanks, Sarah.
So, when it's a great little scenario because those were the three things that every single home was tested for, whether they had cyanotoxins or herbicides, because we did do that for some of the households. But the bottom line is total coliform should never be present in your water. So if you had a total coliform hit in your water and we provided that information to you, then we also said we recommend that you do not drink your water at this time until you get your system serviced and your treatment system serviced. So the answer just because of the presence of total coliform, then yes, you are at risk, and it is for the total coliform contaminants. E. coli was absent in this case, and the nitrate concentration was at 4 milligrams per liter. At 10 milligrams per liter is the action level at which there are potential or real health impacts, especially for young children. So yeah, 10 milligrams per liter for the nitrates, and presence of total coliform and E. coli are public, just the presence of them. You don't even need it to be enumerated how many, it's just the presence of them. So moving back to the other slide, that's scenario one. The contaminant that you are at risk, that is causing your water system to be at risk, is for total coliform, and that's it. So what actions can you take? Well, you can see from the slide prior that you need to boil your water until the problem is resolved. You want to retest, and you should get your system serviced to see what the cause of that is. Sydney, did you have some things to add to that?
Sure. Uh, First of all, I applaud the well owner for taking the initiative to collect water samples. That's already an action, and you want to do that action after. If you do get a service provider out there to maintain your system, you want to follow up with another water quality sample. And then we'll get into some of the other actions later in the presentation that you can take, but checking out the wellhead area to make sure there's no routes of contamination would be another good step that you could probably take as a homeowner. And yeah, we'll cover more after that. So with that, I'll introduce myself. I'm Sydney Little. I'm a staff engineer with the State Water Resources Control Board Division of Drinking Water. I've worked a lot with regulated water systems. I work in an office where we go out. There's about 9 of us, and there's 480 water systems. So I thought that number earlier was interesting. The 493 self-supplied, approximately around the lake, and we spend time combing through a single water system to make sure that they meet all state and federal drinking water requirements. And it's been great to be a part of this team over the years to learn more about the self-supplies space and what treatments in place, what support and resources are there or not there. So with that, you should have received an email inviting you to this meeting tonight with a water system hazard category. And just to let you know, there's fairly limited information available about self-supplied water systems, but the information we did have for the intake systems, we looked at whether or not you had a filtration system or not. And then for all the water systems, we looked at whether or not there was disinfection and maintenance activities. And then for the domestic wells, we looked at how far away are you from a surface water body, and what were your surface construction features, and really collaborated with some team members here to look at photos to just get a sense of kind of if there were any improvements that could be made. Next slide. And don't hesitate to ask any questions. There will be a slide to ask questions, but if there's a term I'm using that you're not familiar with, please don't hesitate to put it in the chat or let me know. This slide, the top part of this iceberg and what we can really visually measure, visually observe, these are the parameters that we were able to look at and use as part of building this water system hazard category. How often you maintain the system, how far you are from a water body, what are the surface well features, general treatment for surface water, and the water quality testing was not built into your water system hazard category because we were looking at how did the water category, the hazard category, compare to the water quality testing done. And I want you to know there are a tremendous number of factors that just are not available for us to consider, but are important. And so There's a number of them. I'm not going to cover them all, but you know, a simple thing like not having a flow rate or a raw water tap, or knowing without that flow rate, we can't tell how much water is being pushed through that filter. And that's a critical piece that goes into the design stage. And other pieces. So next slide. So these are the steps that we took to build the water system hazard category. We awarded points for any safeguards you had in place. For example, if you were far from a water body, you would have more safeguards for a domestic well, and you would have higher points awarded to you. If you maintain the system, your surface well features, and we'll get into those in a minute, are in good shape. For those intakes, if you had a multi-barrier approach, filtration and disinfection, you were scoring more points. And then the next step, we assigned you a category based on how many points were accumulated. So the more safeguards you had, the closer to the minor water system hazard category. With fewer safeguards, you were closer to the major category, and then those that were in between were assigned this moderate category. And then all participant water quality testing is summarized after each section by water system hazard category. Next slide. So to get started, all of the 55 participants were considered for the disinfection portion. It's a really critical treatment process. If you have a well-constructed well with no bacteriological contamination, it's possible, but good practices is to have disinfection in place. And then, let's see, and there's some references to some pathogens that we look at in the regulated space. We look at the ability to reduce viruses, and Giardia specifically. One of those approaches might be using ultraviolet, and that's the first row there. And we just assumed that it was a Class A instrument or device with NSF certification of 55. And this is a wide spectrum disinfectant, and you were awarded 5 points. Though we didn't have all the information to be able to determine whether or not which class ultraviolet devices these were, but we went ahead and assumed that this was the device in place if you had it. And then we looked at chlorine. If it was there, but there wasn't a residual, then you were awarded a fewer points. And the higher the residual, the more points you were awarded. And then ozone, a very wide spectrum disinfectant. If you had it and didn't have a residual, you were awarded 2.5. And then if you had a residual, you were awarded 5. And we just gave systems the benefit of the doubt in this particular category. Now, you could score a possible of 10 points, but if you have 5 points, you're doing really well, especially if you have a filter in place to work in tandem with the chlorine system. But yeah, we'll get to the other pieces next. So up to anywhere between 5 and 10. And then maintenance, there was 2 categories here. If you had annual maintenance or reactive maintenance, you weren't scoring as high as the quarterly maintenance. If you're an intake system, it's pretty critical, especially if you're relying on Clear Lake as a source. You want to maybe seasonally take a look to make sure it's operating optimally. And there's even risks for it, especially during this time of year. There's some compounds that can show up in the lake that are really challenging for your disinfection system. So not a bad idea to do quarterly. Next slide. And then for the domestic wells, we had about 70% of the participants were in the domestic well category. And this is taken from the Department of Water Resources Well Bulletin Standard. It's just pretty typical of what we saw from the participants. And there's a lot of different configurations that can be involved for a domestic well. But one good aspect is to have a vent. I did not see very many vents on most of the systems that participated. It's not shown here, but it's pretty simple to put one in. You can use some PVC pipe. You want to make sure that it terminates above the flood level. You want it to be U-shaped, and you want to screen that to make sure that it no insects or animals can enter into your well. And then it also helps if you have a deeper well, it will help prevent that from collapsing from any pump action. And then there's other features to the well that we looked at. We looked at to make sure there was a concrete base or a concrete pad. And here's the typical dimensions for that. We looked for cracks. If there's anything that's, the drop pipe or the power cable, over time, they can open up. If a bolt is missing, if the gas gets worn, you want to make sure it's just watertight, completely watertight. And then next slide. So for this, we looked at the surface construction features of your wells, and you scored points if there was a actual concrete pad present and free from cracks. If it was generally watertight with no holes, your well cap. If a vent was present, and very few had vents. And then we also considered whether or not you were located in a flood zone. If your well is inundated and it has any openings, then it's potentially contaminated from any flood water. And the possible score for this category was 10 points. Next slide. And then we considered how far you were from a surface water body if you were a domestic well. If you were right on top of that water body, you didn't get any points. You're pretty high risk there for contamination. The further away, we gave you up to 10 points if you were 50 feet or further away, and prorated you basically if in between 0 and 50 feet. Next slide. So we wanted to just share some examples of what we saw. This is a domestic well that in our organization, if we were to come across something like this, we would regulate this actually as a surface water system, even if it had well construction features. And this system only had ultraviolet disinfection. And I just wanted to, there were 5 points awarded for that. One of the challenges for an ultraviolet disinfection system is if the cloudy water that you're seeing is entering the water system itself, it could interfere with the ultraviolet neutralizing any of the pathogens. And so this system would benefit likely to have an upstream filter of some sort to reduce how cloudy that water is. And the results from this particular participant had both total coliform and E. coli present at the top, and there was no nitrate detected. Next slide. So the previous photo was an example of a major water system hazard, and this one is a moderate water system hazard. It had, you can see the photo on the right. You can see the well is, there's a label called casing with a red arrow pointing to the casing of the well. And for this system, there is a disinfection system. There was a residual. It's very low. So they got the 2.5 credit for it. It's not located in a flood zone. However, if this was a system being regulated, we require our casing to be at least 18 inches off the ground. There's likely no holes associated with this. It looks pretty well sealed. It's inside a building. It's got a concrete pad. You'll notice that there's a crack in this pad. That's a pretty simple fix. And to just check the well plate just to make sure it's watertight. And this particular system, the distance to surface water was greater than 50 feet. And so they got 10 points. And there was no bacteriological activity at the top, and nitrate was not detected for this system. Next slide. And here's an example of a minor water system hazard. They perform proactive maintenance. They're not in a flood zone. The surface pad is intact without any cracks. It also has the structure around it, which also helps. The well cap is intact without any holes, and it's about 400 feet from any surface water. Interestingly, this system has a point of use device, which is similar to a water treatment that you might attach to your faucet or under the sink to have a dedicated tap that's got additional treatment. It's really important if you have a device like this to make sure that it's free of any bacteriological activity. And you can see from the results below that this particular system did not, in this snapshot of time, have any bacteriological activity. Some of those can become grounds for bacteriological activity for bacteria to grow. And so you want to be mindful of that. And this system also had no nitrate present. Next slide. I'll turn it over to David.
Okay, thanks, Sydney. Yeah, so we wanted to pause here again. If Terry or if Alex, do you have any thoughts on what you have, for example, this scenario here, where you have a well with the following criteria? Any thoughts on what this water system hazard category might be?
I would say that their hazard category is that they've done well with the chlorine.
Mhm.
They've got to have some filtration in there though. The
Yeah.
chlorine is great. The distance from the creek is great. The
Great.
construction, it looks good. It has UVA. Through all of these, though, it seems to me, at least for you got to have some sort of main filtrate. You got to have some filtration to get some of the bigger stuff out before you even start doing the chlorine on it.
On that, there's a number of types of filters that are available. And yes, if they have a UV system, you definitely want to have some sort of pre-treatment and filter. And then if you're a surface water system, you definitely need to have a filter in place to be able to tackle that multi-barrier approach. If your well is free of bacteriological activity, filtration, UV exception, with the UV exception, you could disinfect just to maintain a light residual to make sure if anything did enter the well at any time and keep the pipes in free also of any bacteriological activity. That would be great and welcome. Excellent, Terry.
Okay.
Yeah, I think just closing on this. Yeah, so the score or the category for this scenario would be moderate. So I think we mentioned, right, placing the vent above a flood zone, making sure it's U-shaped, increasing maintenance to quarterly instead of, just annual maintenance or reactive maintenance. Yeah.
Yeah, and the quarterly maintenance on a system like this, so the UV would have a lamp that would need to be changed probably annually. And then there's the lamp's inside of a sleeve, and that needs to be cleaned periodically. So it's a good idea to have that cleaned regularly. If you have a chlorine system, with a domestic well, it would depend on your water quality changes too. If, with the intake, definitely want to do quarterly minimum. With a domestic well, you might do quarterly to see how things are going that first year in the home, and then assess from there of what it looked like to see if your water quality is significantly changing. If you have iron and manganese and other compounds that have demand, like sulfate and other things that fluctuate, that would be a really good reason to do quarterly a quarterly maintenance piece. And then and checking your checking your well and just inspecting it to make sure it's free of any contamination. You never know if there's a shift of some sort, especially after maintenance is done, or ask them to take a look at it to make sure things are sealed up. And yeah, so that's great.
Hey, Sydney, I wanted to point out on that previous slide, it says that the UV system is not NSF certified. So doesn't that mean that it's not actually um uh falls within, the kind of the acceptable ranges of what could work on a drinking water system. Is that correct?
Yes, you would want to upgrade that to a Class A system. And thanks, Sarah. And a lot of the devices, are really geared towards municipal type treatment systems. And so the water is, again, it's not cloudy. Typically, there's a certain section of straight pipe before it to make sure flows are steady. And there's a lot of maintenance that goes into it, but yeah, that's an excellent point. Yeah, you'd want to upgrade your UV system too. And I'll leave it at that, to the Class A. Yeah. And so here's the 55 homes and how which water system hazard category they fell into. 27 of them fell into the major category, 20 of them fell into the moderate, and 8 fell into the minor. So I think roughly half of them were falling into the major category. And then here's a look at the water quality relative to the water system hazard category. And you can see if you're falling in that major water system hazard category, there was more total coliform present, E. coli present. Nitrate was higher. None of the nitrate, I believe, was above 10, if I recall correctly, from all the participants. But
Correct.
and then cyanotoxins were present for both the major and the moderate. And then cyanobacteria observed was across the board. And this, I don't know if you recall the iceberg picture, there's a number of factors you can't really account for. But if you are in the minor water system hazard category and you're getting cyanobacteria cells in your system, I would definitely look through that system pretty thoroughly. That's if you have a filter, that's potential breakthrough in your filter, may not have been maintained a long time. Backwash could not be adequate. The design could be wrong. And that's just the filter system. There's a lot. The media match might, if it's a multimedia filter, it might not. If there's multiple types of media, they might not be properly matched with one another during that backwash. You might have lost some of your media in the backwash. Yeah, and I think I looked at it, and 4 out of the 16 intakes did have cells present, and that was about 25% of the intake systems, and that was alarming to see.
Thanks, Sydney. So yeah, I think we wanted to pause here and turn it over to you, Terry or Alex, if you had any questions about what's been presented so far, or about your own water system hazard category, any questions at all.
Well, I truly appreciate this work that you guys have done. It was great to get our system tested. We have an intake. We do not have a well. We have spent a fair amount of money, a lot of money on a filtration system, and we have struggled with having clogging of some of our filters from just basically particulate matter. So there's been a lot of struggle in trying to, and we've worked with Benjamin Franklin Plumbing, which is up. And they've been great in trying to help this, but this is kind of an ongoing issue, and we're learning a lot. And so it's good. We actually don't drink our water, but we do cook with it, which now that tells me when I'm looking at the boiling. So that will not be being done. So we think our filtration system does a good job. It's just for so many years, we do bottled water. And sometimes I go, well, maybe we need to get that tested. So I I don't think I have a lot of questions here. I guess my question would be, at some point, we will need to make sure that we get our water tested regularly. And it would be getting names of companies that that will come out and test it.
Great. I think we have some information at the end of the presentation about that. So
Lovely.
stay tuned.
Wonderful. But thank you.
Sure.
We really appreciate you guys doing all this work. And because we've had our cabin for 50 years and this was not done or even thought about for decades. So we really appreciate the work that you guys do.
Thank you, Terry. I'm wondering, you said cabin, so I assume it's a rural setting and not near another public water system as well.
We are not, we're in Bayless Cove near Jago Bay. We're down near in Lower Lake near the bottom part of Clear Lake. We're south of the Riviera, south of Canocti. We are not on any public water system. We're on a little point. There's, I don't know, 20 houses or whatever. Some are on well, some are on intake. Maybe not 20. 20 might not, that's not correct, probably. Less than that. But we have coves. There are coves all around us. So yeah.
So there is a tool to look and see if you know how far apart you are. If you are with a number of neighbors, there's always an opportunity to use the economies of scales to really tackle some of this, especially if there's, 15 to 20 homes out there. You would be regulated by, the state and to make sure that all state and federal requirements are met, which I think is a great thing. And then, and you mentioned a filter clogging. A number of things come to mind, and I'm just curious if you have a disinfection system to really help the filters. Each of these, one of the cornerstones of the surface water treatment approach in the regulation space is a multi-barrier approach. In case, one thing isn't working, you have a backup. Sometimes, depending on the pathogens that are present, they work in conjunction with each other. So, but yeah, I would, recommend reaching out to your neighbors to see if you want to do a larger scale system. And I'm sorry to hear about the clogging. It's not an uncommon thing. Would you believe some systems backwash their filters 4 to 6 times a day during the peak difficult periods of what Clear Lake source water throws at the water treatment plant. So,
yes, and we have had to do that. And the clogging kind of along with the algae's changed over the years, and we have more of it and it's different, and so it's just the particulate matter seems to be different. We have a pipe that basically runs into the lake, so many feet into the lake, and pulls and sits a couple feet above the bottom and pulls from there. And we've done it this way since we've had the cabin. But yes, so it's a constant adding maybe a new filter to block out bigger stuff, and then we go into smaller stuff, and we have chlorine, and so it's been a lot of learning on us, and it's good because we're just trying to do the best that we can to make sure the water is as safe as possible.
great. And if you ever smell ammonia off the water at all or in your own water,
No.
okay. Good to hear. Good to hear.
What would that be? So tell me, what would that mean?
Your disinfection system would not be able to handle it, and you should move to an alternative source of supply.
Okay, good to
at that
know.
point. Yeah.
Thank you. Thank
Yeah.
you.
Okay, I think I'm gonna move us along, since we have about 15 minutes left. I think we'll skip the third scenario, but Sydney, I'll turn it back to you.
Okay. I've mentioned this multi-barrier approach, some actions to consider if you're an intake. We look at filtration and disinfection as a minimum requirement, and just know the Clear Lake water systems around, the lake, they have numerous unit treatment processes in addition to filtration and disinfection. Some considerations, we were talking about the clogging scenario. We would look at how much water is going through your filter. That's the filter loading rate. There's backwash rates, the operations of it, and the inspections. we look to, we don't measure it, but one good rule of thumb is to just make sure your filter is reducing, and anything 1 micron or larger. It will work really well with your disinfection system. And then your disinfection considerations, you want to check residuals. I think you should aim for something high, like a point, I say high, but a 0.5 is pretty protective for a system like this. If you do water quality sampling and you find bacteria, look for an alternative supply. And just a reminder on that UV system, and if it's cloudy, to possibly install a filter to reduce that, or look for an alternative disinfectant, because it's just not compatible with cloudy or turbid water. Next slide. For wells, this is just a review of what we discussed, but consider installing that vent, and installing that surface pad that slopes away from the well. Keep those cracks repaired. Make sure the well cap is watertight. It would be amazing if you could get that well log. It's got a wealth of information in there, and it might help. Some systems may be in fractured rock, and you don't want to chase that one. That one's really difficult to address and requires a lot of additional treatment. It's helpful information to know what's in that well log. And then if you do have a domestic well, if you're going to do a bacteriological sample, I would wait about a day to 2 days after a large precipitation event. And if you're doing really well during that event, that's demonstrates some robustness to your system. I still recommend, periodic monitoring, but that's when I would look at a domestic well. Next slide. And then I think I'll turn it over to Sarah here if I remember. I'm sorry. For all cases, you want to do routine water quality monitoring. There are some, if you're getting a device, you want to make sure that it's got these symbols on it: NSF, Underwriter Laboratories, Water Quality Association, and others. Only use those devices on your sink or under your sink or at your sink if you're sure there's no bacteriological contamination. The exception of that would be ultraviolet. If microcystin is present and no bacteriological contamination, there are devices that can reduce microcystin. They are designed for municipal systems, but they are out there. And then you want to maintain all your treatment and equipment. Next slide. And I just want to highlight this work that was done. It's only a snapshot in time. It's not a comprehensive ongoing monitoring effort. And if you don't have the presence of bacteria or a contaminant, it doesn't mean that this is a sound treatment approach for all time, all seasons, all water quality conditions. Just know when a system does go in for a regulated system, there is a lot of time spent looking at the raw water quality over all the different parts of the year to make sure that the worst case scenarios are accounted for. The great news is there are some actions that you can take as a homeowner to minimize potential threats. That's the upper part of the iceberg. However, there's the lower part, that there's some factors that you can't see. If you don't have that well log and you're in fractured rock and you just don't know that can be really challenging. And so a lot of those might require significant changes to your design or routine water quality monitoring. Having a full-time certified operator out there is just cost prohibitive, I imagine, but there are potential factors present beyond your control that can potentially create hazards at different times of the year. Next slide. And I've been talking about these regulated public water systems. The design's rigorous, certified people out there for complex systems, intense monitoring, they're equipped with alarms, which really give them this ability to proactively anticipate water quality changes and adjust treatment. The source water quality and more are monitored to anticipate the treatment shifts. And systems are constantly adapting and optimizing, maintaining equipment, and planning for future regulations. We've got a number of regulations that have just rolled out as of October 1st that water systems are preparing and for. Next slide. And I just wanted to show you I looked for a simple schematic of intake system because I haven't talked a lot about intakes, but this is what it would look like to meet the surface water treatment rule for a system relying on a reservoir, an open reservoir. And you can see a lot of pre-filtration in here. We haven't mentioned it, but some systems do use membranes, and that's a great way to make sure you get that 1 micron and above removed. That would be an ultrafiltration membrane system. And then there's a disinfectant applied. It goes through a pipe loop to make sure that the chlorine spends time with the water to work on the pathogens, the virus and Giardia in there. And then it goes out to the system. And there's even some granular activated carbon. And I apologize for all the acronyms on this one. And there's also ultraviolet disinfection. So this is what would be involved for about a 10 gallon per minute system, comparable to a potential intake. Next slide. And then we talked about the possibility of connecting households to a public water system, or even those households, if there's a number of them connecting to each other. There is a contact here, Kira Brown. And then also there's a link to this outreach tool where you can type in your address and see how far away you are from a public water system. And there's my email if you have any questions or need more information. Next slide.
Can you email us these slides, or can we get a copy of some of this just to make sure we have some of this information?
Yeah, definitely. Yeah, I'll email the slides after the presentation.
That would be great. Thank you.
Yeah, just pausing here. Any other questions before we move on? Terry or Alex?
Not for me.
No, I don't have any questions, but I just want to thank you guys for doing this. I've learned a lot, so it's been really interesting.
Sounds good. Thanks, Alex, and thanks, Terry, for
David,
joining. Yeah, go ahead.
David, I just wanted to ask Terry and Alex a question, which is, did either one of you have results that were concerning when the water results came back to you?
So we had our water tested twice. The last time was last year. The first time we had it tested, we did have some, and I don't remember exactly what we had in it, but we did have some concerning components in the water. We improved our filtration system. The last time it was tested, we did not. But we're also realistic when we get these algae blooms and things like that in Clear Lake, we're always, we're always really hesitant, and we just try to make sure that we try to keep on top of the filtration system. But so we do the best we can. But no, we didn't last time, not a year ago.
Thanks. Because you did have some issues that first round of testing, would you be interested in doing a half-hour conversation with me? I'm doing an evaluation of the program and its impact,
Sure.
and looking for participants to interview.
Sure. Yeah.
Thank you. I really appreciate it. I'll reach out via email.
Okay, great. No problem.
And Alex, the same offer goes to you. I don't know if you did have problems, but if you'd be interested, let me know.
Yeah, okay, yeah. I've only had the water tested once, and there was no problems from what I remember. So, which is kind of amazing because it's a well and there's no filtration system on it or anything, which I'm looking to change.
Okay. Sarah, do you have Terry and Alex's email? Or
Yeah, I'm not sure which Alex this is. Maybe I know this is being recorded, so Alex, if you want to do like can they do a private chat? Yeah, if you can, you're on an iPad, but if you don't mind sending your email in the private chat to to any of us, or to me, or Tracking California, that would be good. And then that way your email isn't in the recorded item. And then I can look it up because yeah, with the first name, I'm not sure. I know who Terry is, though. I remember
Yes, I've
working with you, Terry.
communicated with you. Yes.
Yes, yes.
Thank you so
Um,
much. I really appreciate it.
And also, Alex had just mentioned, not being retested. Yeah, the protocol we used is if people had detects that were above that public health threshold, like we were speaking about earlier, then we offered a retest to them the following year. And some people took advantage of that, and did that, and some didn't. But if your system if you had no presence of E. coli or total coliform and your nitrates were below the action level, and you weren't anywhere near a water body, which would have you possibly have cyanotoxins in your water. And I think you said you had a well, Alex. So yeah, probably there was no you didn't fall into that category of needing to retest. However, yeah, we're in year 5. I know we're doing some interesting things for year 5, and perhaps would be looking at some other potential contaminating activities happening along wells that weren't that had good water that we tested, in the early year in year 2 or 3, and maybe they'd be eligible for additional testing for year 5. But we'll be checking that and getting back to you.
Great.
Any chance the so the grant was for 5 years. Any chance there will be a continuation of the grant, or I'm sure there's more work that can always be done, I guess so. I'm just curious.
I mean, Terry, I want to offer that anytime that you want to see if there's cyanobacteria in your, in your water, we do microscopy in-house. And so we can always take a look at your water for any presence of cyanobacteria. So I'm always happy to look at that. But I want to, yeah, just point that out, and maybe Susan or David could discuss kind of what the next years look like.
Yeah, I'm happy to jump in there. I don't think that we will get a grant that will continue in the exact same way. It's rare for that kind of thing to happen, but we are actively looking for funding to support some of the things that have come out of this project, some of the parts that we didn't discuss on this call. And talking, Sydney and I just had a conversation about some ways that we might be able to change policy or regulation. So in order to make people more aware of the issues, might be able to do some training of water system suppliers, and a number of other things that feel like they would be really useful and impactful going forward. So that's definitely ongoing. I don't have any promises of anything right this minute, but I do look for grants just about every week on Friday. So hoping to find something soon.
And Sarah, I think this is
I
for
slide.
you. Yeah.
Yeah, so part of the resources that we sent out to the group, I don't think we actually included these when we were originally testing your water, but these are some great links for products and devices that will meet your needs. These devices, you want to make sure that your devices will reduce the contaminants, and in California, it will state on the packaging what the reduction of contaminants is. And the goal of the state of California's water treatment device registration program is to ensure that devices sold in California have been independently evaluated and tested to reduce health-related contaminants as claimed by the packaging. So that's required in California. There is a link for Imperial Valley that shares their experience about treatment system maintenance, and I believe that's the IAPMO. Is that correct, Sydney? Okay. And there are CDC guidelines for bacterial issues as well on that link. And then in terms of, oh yeah, so there's the Imperial Valley. And you can find out more information from the state of California in terms of is our water safe to drink? There's some good testing that they're doing, and you can look at the statewide maps. And there is also finally the CalWatch resources page, which we sent out originally. And if you have the link, the original link that we sent out, it no longer works. I mean, there's been some changes to the website and whatnot. So this is the updated resources page. So please take a look at that when you get a chance. Oh, Sydney, did you want to do this one or do you want me to? Or
Yeah, sure. These are certified labs listed here. Alpha Analytical, Barelgi and Race in Santa Rosa, and Clerk in Lake County. They only do the bacteriological. And then there's a list of labs. You want to do the microsystem lab list, Sarah?
yes, no, this is a 2021 microsystem lab list, and this is for water samples to test for microsystem, one of the cyanotoxins. I can tell you that Big Valley uses Bend Genetics for and also Greenwater Labs, which is in Florida. So a bit of a distance to mail it. But those are the two labs that we use for cyanotoxins. Big Valley has actually purchased the equipment and the training from Kennedy Environmental. So we're going to be doing some in-house microcystin cyanotoxin testing. We've already started to do that, and we'll be expanding to homeowners and others in the near future. So keep an eye out for that. We'll be putting a lot of announcements out regarding that. But until that point, or even after, the list on the in the table, Bend Genetics on down, the list to Greenwater Labs is where you can send water samples off for cyanotoxins. And a lot of them will do microscopy as well. So you can see what cyanobacteria is in your drinking water, if anything. But like I said, we also do that in-house. I'm happy to help people out by looking at their water samples.
Okay, I think these are the last two slides that we have, but yeah, I just wanted to point out that if you made changes to your treatment system since we last tested your water, and you're interested in a retest, we have this form here. You can also scan the QR code. I'll also be following up with you both, Terry and Alex, regarding as a thank you for participating in our webinar, an online gift card. And definitely feel free to reach out to me if you still have questions or concerns. And just lastly, we really want to appreciate both of you for taking the time to join us this evening. And this project wouldn't be possible without the funding from the CDC and then just all of our collaborators here that worked on this project. Sarah or Susan or Sydney, anything else that you want to mention?
Well, just want to thank all the participants, and I know, with two of you being on, it's fantastic, and I know others were unable to make it, and we will be sharing the slides for this. Is the recording going to be shared as well?
Yeah, the recording will be made available too. Yeah.
Okay, and I believe we'll be putting this out, so please feel free to share it with others. And it's still possible to do if for your neighbors or friends who haven't participated in the CalWatch program. We're still open to sign up new people and test their water and go through the same thing, and do a workshop for them after it's done. And please share our information so we can work with others as well. And thank you so much for participating.
Yeah, and I just wanted to add one quick thing. Going out for those devices and finding the NSF and going to all the sites, it can be challenging. It hasn't been streamlined yet, but it's an effort everybody recognizes in the industry. And so when you do go out to buy your packet, your device, look for the symbol and then maybe look it up to see what it reduces. And know that there's some clever equivalents out there that appear to be certified but are not. So be on the lookout for those too.
Thank you.
Thanks. All right. So I guess with that, I'll stop the recording. And yeah, thanks again, Terry, and thanks, Alex, for joining. Thanks, Sarah. Thanks, Denise and Susan. Appreciate your time this evening.
Yeah, thank you. Thanks for putting this on.
Yes, thank you.
Thank you
Thanks,
both.
everyone.
Thanks.
Cool.
Right.
That was great.
Oh my gosh.
Really great.